Good evening, and welcome to ECE News. I'm your host, Derek Mead. Tonight we'll be discussing the ongoing climate crisis, how it started, how it's going, and what we can do to save ourselves. Our first correspondent tonight will be talking about ozone depletion. Over to you, Josh.
We'll be talking about the different layers of the atmosphere. So the first closest to the Earth is the troposphere, then goes the stratosphere, the mesosphere, the thermosphere, and then the exosphere. The stratosphere is where you'll find the most important ozone layer. It's the ozone layer that helps protect us from ultraviolet radiation from the sun by absorbing most of the ultraviolet radiation the sun sends to us. Life as we know wouldn't be possible without this layer of protection. Next, we'll be talking about ozone. Ozone is a highly reactive gas composed of 3 oxygen atoms. It is both a natural and a man-made product that occurs in the stratosphere and troposphere. Stratospheric ozone is formed naturally through the interaction of solar ultraviolet radiation with oxygen. Tropospheric ozone is formed primarily from photochemical reactions between 2 major classes of air pollutants, volatile organic compounds, and nitrogen oxides. When chlorine and bromine atoms come into contact with the ozone layer in the stratosphere, they destroy ozone molecules. One chlorine atom can destroy over 100,000 ozone molecules before it is removed from the stratosphere. Ozone can be destroyed more quickly than is naturally created. So now we're going to be talking about tropospheric versus stratospheric ozone. Stratospheric ozone is considered good ozone, while tropospheric ozone is considered bad ozone. Stratospheric ozone is considered good because it is higher in the atmosphere and it blocks out dangerous ultraviolet rays from the sun. It doesn't have any negative effects on humans or the environment. Tropospheric ozone is considered bad ozone because it's closer to us and it's in the air we breathe and has dangerous effects on humans and the environment. It is created by car emissions, power plants, industrial boilers, refineries, chemical plants, and other sources that chemically react in the presence of sunlight. So next we're going to be talking about solutions to ground level ozone. One way the U.S. tried to solve this was by the Clean Air Act. It was an act that helped solve air pollution problems. And another way is to use cleaner energy. And we could do this by solar panels, other ways of using energy, not by burning fossil fuels. We could also solve this problem by reducing car emissions, by either using electric cars or more public transportation. Next, we're going to be talking about the ozone hole. So each year during the southern hemisphere, spring in Antarctica, chemical reactions between chlorine and bromine destroy ozone very severely, and it creates what is known as the ozone hole. At first, for several years, the minimum concentration stayed in the 190s in the Dobson unit. As time went on, the minimums decreased greatly, such as 173 Dobson units in 1982, 154 in 1983, and 124 in 1985. In 1991, the minimum went down even below 100 Dobson units, which was the first time that was ever seen. It is now common when it goes under 100. Since the ozone hole completely destroys ozone, it comes with a lot of negative effects because the ozone protects us from ultraviolet radiation. It could cause certain types of skin cancers, eye cataracts, and immune deficiency disorders. Lastly, we'll be talking about the Montreal Protocol. The Montreal Protocol is a global agreement to protect stratospheric ozone layer by phasing out the production and consumption of ozone-depleting substances. It was finalized in 1987 under Ronald Reagan's presidency. It was also the first treaty to achieve universal ratification by all countries in the world. The protocol has taken action on reducing the production of chlorofluorocarbons and halogens, which harm the ozone layer. It is estimated that the Montreal Protocol would avoid 443 million cases of skin cancer, approximately 2.3 million skin cancer deaths, and more than 63 million cases of cataracts for Americans born between 1890 and 2100. Scientists confirmed that the ozone hole in 2021 closed a few days earlier than the hole in 2020, which shows that we're stepping in the right direction. And now on to you, Amber.
Thanks, Josh. Today I am going to be talking about some of the causes of global climate change. First, I'm going to identify greenhouse gases. Greenhouse gases are in the Earth's atmosphere and they trap heat. 80% of greenhouse gases are carbon dioxide, 10% is methane, 6% is nitrous oxide, and 3% are HFCs, PFCs, and other gases. Further, most greenhouse gases come from burning of fossil fuels, such as coal, natural gas, petroleum, and other gases that are used to make energy. Emissions can come from transportation, houses, and many other everyday activities. The greenhouse gas effect is a process that occurs when gases in the Earth's atmosphere trap the sun's heat. This process makes Earth much warmer than it would be without an atmosphere. The greenhouse effect is one of the things that makes Earth a comfortable place to live. However, with more greenhouse gases today, the world is heating up a lot more than needed. Greenhouse gases are necessary to regulate the Earth's temperature, as they help trap heat from the sun. However, with the recent increases of greenhouse gases, there is an excessive amount of heat in our atmosphere and is retained, causing Earth changes that should not occur. Global carbon emissions from fossil fuels have significantly increased since the 1900s. Since 1970, carbon dioxide emissions have increased by about 90%, with emissions from fossil fuel combustion, and industrial processes contributing to about 78% of the total greenhouse gas emissions, increased from 1970 to 2011. Agriculture, deforestation, and other land changes have been the second largest contributors. Next, I'm going to be talking about particulate matter that also affects our atmosphere. Particulate matter is a complex mixture of extremely small particles and liquid droplets. Particulate matter is normally 2.5 to 10 micromoles big. They can often cause short-term health effects such as irritation to eyes, nose, throat, and lungs, coughing, sneezing, runny noses, and shortness of breath. Exposure to fine particles can also affect lung function and worsen medical conditions such as lung cancer, asthma, and heart disease. Suspended particulate matter are finely divided solids or liquids that may be dispersed through the air from combustion processes, industrial activities, or natural sources. These particulate matter particles are less than 10 micromoles, unlike regular particulate matter. Cardiovascular effects can be caused by this particulate matter such as cardiac arrhythmias, heart attack, and respiratory effects such as asthma and bronchitis. Next, I will talk about the EPA's regulations. Carbon monoxide, lead, mercury, ground level ozone, nitrogen dioxide, particulate matter, and sulfur dioxide are the EPA's regulated air pollutants. Lead is a naturally occurring element found in small amounts in the Earth's crust. Mercury is persistent, bioaccumulative, toxic, and it is a pollutant. Volatile organic compounds are emitted as gases from certain solids or liquids. Volatile is meant as being able to evaporate at normal temperatures, such as benzene. Primary pollutants are an air pollutant emitted directly from the source. Secondary pollutants, however, are formed in the lower atmosphere by chemical reactions. Next, I will talk about the effects of El Niño and La Niña in our environment. El Niño is the warm phase of the El Niño Southern Oscillation and is associated with a band of warm ocean water that develops in the central and east-central equatorial Pacific. La Niña is an oceanic and atmospheric phenomenon that is a colder counterpart of El Niño, as a part of the broader El Niño Southern Oscillation climate pattern. La Niña is along the tropical west coast of South America, and El Niño is near the eastern equatorial Pacific Ocean. Currently, we are in the La Niña event and also in La Niña watch, according to the NOAA, or National Oceanic Atmospheric Administration. New England often sees a slightly warmer and wetter than normal winter when we are in this La Niña event. The economic concerns are higher food prices and inflation from constraints of the supply and rain-driven agriculture commodities. Lastly, I'm going to talk about some fuel types and their pros and cons. Fossil fuels are the major fuel type, and some of the cons are that it's not renewable, they pollute the environment, and in the case of irresponsible use, they can be dangerous. The pros include that they are easier to store and transport, and it is really cheap. And they are also more reliable than renewable energy. They release large amounts of carbon dioxide into the air, and these greenhouse gases trap heat in our atmosphere, causing global warming. The exhaust from cars, trucks, and buses release nitrogen oxides and sulfur dioxide into the air, which cause acid rain. Natural gas have cons that include that it's not renewable, it's a large air polluter, and it causes acid rain and ozone depletion. However, some of the pros include that it is a major power source globally. It is extremely safe, reliable, and independent of weather. Lastly, an option that many people are starting to use is a nuclear option of energy. Some of the pros include that it has low carbon emissions, it is cheaper to produce. However, it has some cons. Some cons include that it produces nuclear waste, and it is very dangerous. Over to you, Brooke.
Thank you, Amber. And now I'll be talking about the effects of global climate change. So first, why don't we explain climate change in an example of a positive feedback loop? So climate change can be represented in several ways, but as I said previously, we're going to use a positive feedback loop. Dufresne uses this scenario to emphasize how climate change could be represented by this. When the surface temperature rises, part of the ice and snow melts, leading to an increase in the solar radiation absorbed by the surface and to an enhanced surface warming. And so we can also discuss industrial and photochemical smog, where industrial smog is formed when fog intertwines with smoke and sulfur emissions, burning, creating smoke and sulfur dioxide. This smoke and sulfur dioxide mixes with the fog and creates a thick haze lower on the ground. And with photochemical smog, it's formed by a mixture of pollutants with nitrogen oxide and volatile organic compounds react to sunlight, and it presents itself as a brown haze above cities. And we can also talk about our temperature changes, where our temperature for surface temperature has risen by 0.18 Fahrenheit per decade since 1880, and this is via by climate.gov. And in the last 40 years, that has actually doubled from 0.18 to 0.32 each year. So Connecticut has seen its climate go up by 2 or 3 degrees in the last century, where our springs arrive earlier and they bring more precipitation than normal. Rainstorms are more common, and summers are drier and hotter. And within these changes of precipitation, droughts versus snow and precipitation, because of these constantly rising temperatures, it means that weather patterns are changing amongst different countries. And as I said previously, Connecticut has seen this personally in itself. And warmer oceans result in more evaporation, leading to heavier precipitation and more intense snowstorms. And so because of this, we can also see sea level changes. And for one, if you've seen one of the CNN articles of a Zillow house in North Carolina collapsing due to the rising sea levels. Previously, even 20 years back, that sea level was way receded, and then now we can see that there was an evident change in the sea level rising, which caused the house to collapse. Our glaciers and ice sheets are also melting in the ocean. Antarctica, for example, we've lost 13% of the polar caps each decade since 2000. And our global sea levels have also risen by 7 or 8 inches since 1900. And we can move on to our changes in global ice, where we can also reference Antarctica again. Antarctica represents itself as our world's refrigerator, and it's what keeps our world in balance. However, due to climate change, Antarctica is in danger of losing its purpose. Not only Antarctica, but the Greenland ice sheet as well. We lose on average 13% of our polar caps each decade, and given our increasing surface temperature, we can expect to lose more of it. Should we also lose the entirety of the Greenland ice sheet, we are expected to see the sea level rise by at the very least 20 feet. And finally, we can see how it changes and how it places its effects in our everyday life, such as the aquatic sea life and our atmosphere as well. When focusing on humans, our climate change has affected us to the point of us moving out of our countries. While most people stay in their country of origin, there are those that cross borders to move into a more sustainable climate. Not only that, but the increasing temperature has encouraged more pests to come out into the atmosphere. Because of the increasing temperature, we often see more of these pests out and about. It gives them more of an opportunity to find other fellow pests, mate, and continue the life cycle. Climate change is also affecting aquatic life as well. Because of the surface temperature warming the ocean, this means that the temperature of the fish is now becoming warmer. It has caused coral bleaching and loss of breeding grounds for mammals and other aquatic species. We've lost 14% of our coral reef due to rising ocean temperatures. And now I'll pass it on to Eric.
Thank you to Brooke and the rest of our correspondents. I will now be finishing by talking about solutions to climate change. The Kyoto Protocol. The Kyoto Protocol is an agreement facilitated by the United Nations between 192 countries to limit the amount of carbon emissions. It was the first international agreement of its kind to try and curb emissions. It relies on more industrialized countries to lead the way in cutting greenhouse gas emissions, and therefore has loftier goals for said countries, like the US. This protocol was adopted in December of 1997 and became official in February of 2005. The debate over the Kyoto Protocol is that it has a lot of major issues, including that it doesn't focus on other pollutants like sulfur dioxide and doesn't include the world's largest economies like China and the US, which declined to sign up. Our next solution is carbon offsets. Carbon offsets are basically just reductions in emissions by storing more carbon through the restoration of land or the planting of trees. Offsets are used to counteract the effects of emissions in other areas. For example, if a business is making a lot of emissions in one area, they can plant trees in another area to make up for it. According to OffsetGuide.com, the key concept is that offset credits are used to convey a net climate benefit from one entity to another. Because GHGs mix globally in the atmosphere, it doesn't matter where they are exactly reduced. Carbon sequestration is our third solution. Carbon sequestering is the name given to the process of storing carbon. There are two types, geologic and biologic. Geologic sequestering is achieved by pressurizing the carbon until it's a liquid and then injecting it into porous rocks in the earth. Biologic sequestering is the storage of carbon in plants, soil, and aquatic environments. According to the U.S. Geological Survey, in 2013, the USGS released the first ever comprehensive nationwide assessment of geologic carbon sequestration, which estimates a mean storage potential of 3,000 metric tons of gigatons of carbon dioxide. Our fourth solution is the use of renewable fuels. According to the World Wildlife Fund, nearly 40% of U.S. CO2 pollution comes from power plants burning fossil fuels. According to IRENA.org, renewables could supply 4/5 of the world's electricity by 2050, massively cutting carbon emissions and helping to mitigate climate change. But solar and wind power have to be fully integrated, with sustainable bioenergy providing another key part of the mix. Switching to renewable energy will be very hard to do, as it will be expensive and require a lot of time, work, and collaboration. Lastly, our fifth and final solution, efficiencies in our lifestyles. The National Resources Defense Council says that you can help to stop the climate crisis in your everyday life. You can power your home with renewable energy, buy energy-efficient appliances, waste less water, waste less food, drive fuel-efficient cars, carpool places, use public transportation, and recycle. Even doing a few of these things helps. The power is in your hands. That's it for us here at ECE News. Thank you for watching. Please tune in next time.